Standard 10. Topic: Sphere and Hemisphere. Learning area: Mensuration. We have heard about the solid figures in our earlier classes. Have we ever seen those figures in our real life? Yes. Here are a few examples of these solid figures. You can see a lorry. Each part of the lorry is solid figure. We can see cylinder, sphere, cuboid, and other solid figures. Here is one more example. You can see a boy playing with a coconut shell. He fills the coconut shell with sand. Can you measure the amount of sand? Yes, we can measure. In this lesson, we are going to learn how to find volume and surface area of sphere and hemisphere. At the end of this lesson, the students will be able to understand the concept of volume and surface area of sphere, understand the concept of volume and surface area of hemisphere, understand the concept of volume and surface area of combination of solids, and solve a few word problems on calculating volume and surface area of solids. Let us learn about sphere now. What is sphere? Sphere is a solid described by the revolution of a semicircle about its diameter, which remains fixed. You can see a sphere on the screen. In the sphere, AOB is the diameter of the sphere. The sphere shown is generated by one complete revolution of the semicircle about the diameter AOB. The center and radius of the semicircle are the center and radius of the sphere. Let us learn how to find the volume and surface area of the sphere. Let R be the radius of the sphere. Volume of the sphere is given as 4 by 3 pi r cube cubic unit. In the same way, the surface area of the sphere is given as 4 times pi r squared square units. Using these formula, let us work out a few problems now. Example 1. The radius of a sphere is 3.5 centimeters. Find the surface area and volume of the sphere. Solution. Here, the radius of the sphere is given as 3.5 centimeters. We know the surface area of the sphere is given as 4 times pi r squared square units. On replacing the radius of the sphere in the formula, we get 4 times 22 by 7 times 3.5 squared. On further simplification, we get the surface area as 154 square centimeters. In the same way, we can find the volume too. We know the volume of the sphere is given as 4 by 3 pi r cube cubic units. On replacing the radius of the sphere in the formula, we get 4 by 3 times 22 by 7 times 3.5 cube. On further simplification, we get the volume as 179.67 cubic centimeters. Thus, the surface area and volume are calculated for the given sphere. Example 2. The surface area of a sphere is 1386 square centimeters. Find the radius of the sphere. Solution. Here, the surface area of the sphere is given as 1386 square centimeters. We know the surface area of the sphere is given as 4 times pi r squared square units. On equating both the values and simplifying it, we get r squared is equal to 110.35. On further simplification, we get r is equal to 10.5 centimeter. Thus, the radius of the sphere is 10.5 centimeters. Example 3. The volume of the sphere is numerically equal to its surface area. Find the radius of the sphere. Solution. Here, the volume and the surface area of the sphere is equal. We know the formula of surface area and volume of the sphere. We can equate them and write it as 4 by 3 times pi r cubed is equal to 4 times pi r squared. On cancelling the common terms 4 and pi, we get r by 3 is equal to 1. From this, we can find r is equal to 3. Thus, the radius of the sphere is 3 units. Let us learn how to find the volume and surface area of the hemisphere. Have you heard about the term hemisphere? Yes, it is half of the sphere. When the sphere is cut by a plane through its center into two equal parts, each part is called the hemisphere. Let r be the radius of the hemisphere. Volume of the hemisphere is given as 2 by 3 pi r cubed cubic units. In the same way, the curved surface area of the hemisphere is given as 2 times pi r squared square unit. Total surface area of a solid hemisphere is 3 times pi r squared square units. Using these formula, let us work out a few problems now. Example 4. The radius of the vessel is 4 centimeters. Find the surface area and the volume of this vessel. Solution. Here, the vessel is in the shape of hemisphere. Therefore, the radius of the hemisphere is 4 centimeters. We know the curved surface area of the hemisphere is given as 2 times pi r squared square units. On replacing the radius of the hemisphere in the formula, we get 2 times 22 by 7 times 4 squared. On further simplification, we get the curved surface area as 100.57 square centimeters. In the same way, we can find the volume too. We know the volume of the hemisphere is given as 2 by 3 pi r cubed cubic units. On replacing the radius of the hemisphere in the formula, we get 2 by 3 times 22 by 7 times 4 cubed. On further simplification, we get the volume as 134.09 cubic centimeters. Thus, the curved surface area and the volume of the vessel are calculated. Example 5. Find the curved surface area and total surface area of a hemisphere of diameter 42 centimeters. Solution. Here, the diameter is given as 42. From this, we can calculate the radius of the hemisphere as 21 centimeters. We know the curved surface area of the hemisphere is given as 2 times pi r squared square unit. On replacing the radius of the hemisphere in the formula, we get 2 times 22 by 7 times 21 squared. On further simplification, we get the curved surface area as 2772 square centimeters. In the same way, we can find the total surface area too. We know the total surface area of the hemisphere is given as 3 times pi r squared square units. On replacing the radius of the hemisphere in the formula, we get 3 times 22 by 7 times 21 squared. On further simplification, we get the total surface area as 4158 square centimeters. Thus, The total surface area and curved surface area of the hemispheres are calculated as shown. Let us learn about the combination of solids. In our day-to-day life, we come across a number of solids made up of combinations of two or more basic solid shapes. You can see a truck with a container fitted on its back. It is made of a cylinder with two hemispheres at its end. How about this toy? Yes, this toy is made up of cone and hemisphere. Like this, we can see many solids made up of different combinations. Example 6. Peter made a bird bath for his garden in the shape of a cylinder with a hemispherical depression at one end. The height of the cylinder is 145 centimeters and its radius is 30 centimeters. Find the total surface area of the bird bath. Solution. Height of the cylinder h is equal to 145 centimeters and radius of the cylinder and radius of the hemisphere is equal to r, which is 30 centimeters. The total surface area of the bird bath can be calculated by adding the curved surface area of the cylinder and curved surface area of the hemisphere. That is 2 times pi r h plus 2 times pi r squared. On taking the 2 pi r out, we get 2 pi r times h plus r. On replacing the values of r and h in the formula and simplifying it, we get 33,000 square centimeters. Thus, the total surface area of the bird bath is 33,000 square centimeters. Example 7. Ross kept the jewels in the jewel box and locked it. The dimensions of the jewel box are given as shown here. Find the amount of air present in the jewel box. Solution. Here, the length of the box is given as 15 meter, breadth of the box is 7 meter, height of the box is 8 meters. Similarly, the diameter of the cylinder is 7 meter, from which radius is calculated as 3.5 meters. Height of the cylinder is 15 meters. We know that volume of the jewel box is nothing but the summation of the volume of cuboid and volume of half the cylinder. Note here that only half of the cylinder is used. So, the volumes of cylinder will be half. That is, length times breadth times height plus half times pi times r squared h. On replacing the values in the formula, we get 15 times 7 times 8 plus half times 22 by 7 times 3.5 times 3.5 times 15. On further simplification, we get 1128.75 cubic meter. Thus, the amount of air present in the jewel box is 1128.75 cubic meter.